Hi students, this is Terry. In the last video we have seen what is an ELISA. So we have learned a little principle, right? A little few things about ELISA, the basic principle. So what are the ingredients it has, how it works. So today we are going to mainly focus on indirect ELISA. So what do you mean by indirect ELISA? Before we learn indirect ELISA, we should know how ELISA reader will be. And we have a micro titer plate, or as we say that is 96 well plate. It has 96 wells. And it looks like similar. I can draw here. It has small wells. It has small wells. It's a rough diagram, right? So this side you can see 12 wells and this side 8. So this is the basic idea. In each well we load the samples, the serum. Whatever blood we collected, we just load the sample. So each plate is fixed, or else in the well there are certain specific antigens, or else antibodies will be fixed by using some fixing buffers. Okay, so all the antibodies or antigens will be inside the well. When you buy the plate, inside the plate it's already fixed. Okay, so according to that we are going to do the test. Okay, this one thing. So if I want to go to indirect ELISA, so what do you mean by indirect ELISA? Very simple, it's only few steps. I'm going to draw only one well. I cannot draw all the 96 wells. So what I do, I only draw one well. In indirect ELISA, the inside the well, you can see only antigens attached. Here you can see only antigens attached. There are certain antigens attached. For example, you want to go for a HIV test, this antigen will be HIV antigens. So as we know, if I get infected with HIV, my body will produce what? Anti-HIV antibodies. So these anti-HIV antibodies can be easily react with this antigen. Okay, so we know the antigens will be attached, already present inside the well by using a fixing buffer. Okay, that's the first step. Now we have the sample, blood sample. So we have the serum over here. Okay, now we don't know whether he has HIV or not. So we are taking 2 wells. Same way we take 2 wells. Even in this well, antigens will be present. Okay. Now, I am going to add this sample. For example, he has HIV. I had this sample here, the serum. What will happen? Obviously, we have the antigen here. If it is a HIV sample, this sample obviously contains what? Anti-HIV antibodies. So once I add, these anti-HIV antibodies can easily react with these antigens. It's a one step. Okay, for example, this sample doesn't contain HIV antibodies. So what will happen? It has some other antibodies. So it will not react with these antigens. If the antibody is there, it will react. If there is no antibody, it will not react. Okay. Now, what we do then is next step, we will wash. Very simple. The unbound antibodies will be washed off. We don't need those antibodies. For example, there's 4 antigens, but we have added many antibodies. only 4 antigens will be attached, right? The rest of the antibodies will be floated. So we don't need that. So what we do, we want to wash. So by washing, we use washing buffer. We call washing buffer. By using the washing buffer, we will just remove unbound antibodies. Am I right? The same way, the antigen-antibody reaction doesn't occur here because it doesn't have what? HIV antibodies. So once I wash, what will happen here? All those will be gone. There won't be any antibodies because there is no attachment, there is no reaction. But here what will happen? This antibody antigen will not be washed. Why? This is attached. So unnecessary, unbound antigens or antibody reactions will be washed off. Now, we already talked enzyme linked with one antibody, right? So that antibody we call secondary antibody. Remember? Secondary antibody. So this antibody, the first we added, right? That is primary antibody. Primary antibody. Now we are going to add the secondary antibody. So how the secondary antibody looks like? The last lesson we have drawn one antibody structure. It has enzyme linked, or enzyme is conjugated with this antibody. Now we are going to add this secondary antibody to this well. Secondary antibody. This secondary antibody has a very particular function, that is, it will not go and bind with any antigens. It will only bind with primary antibody. Okay? So why? For further analysis, it may be very helpful. Okay? So I add secondary antibodies. These secondary antibodies will attach with the primary antibodies. This secondary antibody has what? Enzyme. Again, by using the washing buffer, again we will wash to eliminate or to discard unbound reaction. So there will be enough secondary antibodies will be floated there. So we want to remove those. Again, by using the washing buffer, what we do? We just remove. What will happen here? The secondary antibodies, it cannot react with any antigens, right? So what will happen? Once I washed, this antibodies will be removed. So nothing else in this plate. If you don't have HIV antibodies in this well, you can see nothing except the attached antigens. But here, this complex will be formed. It cannot be washed off even with the buffer because the antigen is already attached in the surface of the well. This antigen holds this primary antibody. Primary antibody holds the secondary antibody. The secondary antibody has the enzyme linked. So this is the complete structure. Now the next step. How we can identify whether the reaction happens inside or not. For that reason, we are going to use this enzyme as an advantage. You know, enzyme always react with some substrates. So some substrates and enzyme both together give some colored compound. We say chromogenic substances. So we call chromogenic substances, okay, or substrates. So I'm going to add this chromogenic substrate into both the well. Chromogenic substrates. Once I add the chromogenic substrates, what will happen? The enzyme start reacting with this substrate. The end product will be any colored product. Easily you can see through your naked eye. Any blue color, any yellow color, you can see that. So according to that, we can quantify and we can say how much of antibody or antigen present in this well. So this is easy detecting method. So chromogenic substance, once you add the chromogenic substance, what will happen? The color product will come by using the spectrometry. By using the light intensity, you can quantify how much of amount antibody and antigen presents here. Or you can detect whether it's positive or negative by seeing the color. So this is a very basic idea of indirect ELISA. So always remember indirect ELISA, in the microtiter plate inside only antigens will be present. For some other techniques, antibody will be present. So don't get confused. Indirect ELISA, inside the well you can only see the antigens. So I hope you got clear. Any clarification and doubts, you can ask me in the comment section. Thank you.